here with that cable here into the NMEA backbone. You see, NMEA 2000. And this is fantastic. And I connect the tachometer, the ignition switch, and the information about the engine here into the backbone. And now I can integrate. Look at this. This is analog fuel level, oil pressure, temperature, RPMs. I can connect those analog signals here, and now I can see in this display or this display that information. That's fantastic. And also in my cell phone. Bingo, finito, no? This is the perfect configuration. And also I can connect here my laptop, and I can see both networks. I can see both networks. This is a full integration. This is a full integration. Yes. Now I have 71 watts here. The DC panel consumes 30 watts. And also I can connect the short power here, and I have a full integration between everything right now. Okay, and here, what is this? That's the rudder arm. And here is the rudder arm, and here is the rudder sensor, and they are connected with a link between this, and that link should be calibrated in order to install both of them parallel. If this one is moving like this one is moving like this, and this one is moving like this. Next week I am going to explain that when I install the autopilot, the first step in the installation of the autopilot is say when that link is properly connected, because the rudder is in the 0 position, I say this is my 0 position starting today, and I say synchronization. Immediately the boat recognizes that this is 0. After that is positive, after that is negative. And now that sensor sends the signal appropriated here, and the system works. No? And what about how this linear actuator is connected? You have 3 holes. Here you have the traditional cylinder of the RAM, the power steering. And here in the second one you have this one. What is the function of this one? Correct, correct. And move it this or this. Of course, if I am in autopilot, I don't touch the wheel. And when I am in autopilot, I see that the wheel is moving by itself, because that element moves this one like this or like this. That's okay? That's it. Next week, I am going to prepare here the engine and the connection to see that. But right now, I have connected everything. And I have also my boat, my generator, everything integrated into the system. And the propulsion system also. Because I am charging both battery banks with the solar panels and the windmill. And when one of those solar battery banks, the level of charge decreased more than 30%, immediately the sensor located in each battery bank go here and indicate to the computer that one bank is low, and the computer sends the signal and the generator starts automatically until the level of charge in both battery banks is equal. When the level of charge in both battery banks is equal, the generator stops. In other words, you don't need to connect your boat to the shore power in the future. You are sleeping and you hear that suddenly start the generator. Is recharging battery. And suddenly stop. Okay. Right, no? This is the boat that I want that you design. I think that we don't need to continue with the traditional boats with breakers and switch selectors because that switch selector is automatic. If power is entering here, that one goes here. If that one is not connected and the generator starts, that element goes here to the bottom one. You understand? Yeah. It's automatic. I don't need to move it. I hope you do a boat like this. Who has a boat in your home that you can modify?
Like modified a hybrid? Probably could. Yeah, maybe.
That's more displacement holes, right?
Yes.
It should be right.
Yeah, more displacement, yeah.
Yeah. If you have a safe boat or a catamaran, it's fantastic. That's the best boat to be converted.
Yeah.
That's the
A lot of the new catamarans I see.
Because they have enough room for the panels.
Yeah.
Right,
Fountain Peugeot is
Correct.
putting out hybrid
Correct.
boats now.
And
Yeah.
it's easy to remove the small diesel engine for a couple of electric engines.
Yeah.
And you continue with the same transmission. But this is easy. And this is the best scenario to convert. I hope you convert boats in the future. This type of boat. It's not complicated. Alright, good. Okay, you have your soldering gun. Okay, let's go. I say, when I rectify that signal like this, I rectify from this one into this one. No? Of course, if my input signal AC is 120 volts, the amplitude is too much. When I rectify to DC, probably I have DC 100 because I lose something because the diode drops the voltage 1.5 volts per each in each diode. No, all right. In this particular case, I am going to reduce the input voltage 120 into 20 volts. Excuse me, into 28 volts AC with a step-down transformer. Look at this step-down transformer. In the primary coil, I introduce 120. In the secondary, I have different options. If I read between this and this, between this terminal and this terminal, I have 60 volts output. If I read in between this and this, I have 40 volts. If I read between this and this, I have 30.
And is that listed anywhere?
Yeah.
Or where it says 60, 40, and 30?
60, 40, and 30.
Okay, but it doesn't
No,
say.
no. This particular step down. There are other step down transformers. This one in particular, they have those three options. I am going to use that option, and I am going to rectify that option with my diodes in this position. I am going to introduce the hot, this hot here, and this neutral here in this diagonal, and in the other diagonal I have the negative DC output and the positive DC output. When I do that one here, my signal right now is not like this, it's like this. And now I straight that signal here with the capacitor and the resistor. And bingo, at the end of this, I have a completely straight DC signal. Yes. How can I obtain the exactly value of DC that I wanted, 14.74, with the value of the resistor and the value of the capacitor? When I combine both of them, I rectify better and better. Can I put another capacitor here? Another? Yes, in order to rectify better or reduce a little more. Can I put another? Yes. This is why you have sophisticated rectifiers and Mickey Mouse rectifier that only like this, only have one capacitor and one resistor. You you can modify better and straight the signal perfect with a more capacitor and more resistors. We are going to do that one. And we are going to change 120 into 14.6 or 15 volts DC. Wow. We convert AC into DC. But the secret is locate the diodes in the proper position. Look, this is the symbol of the diode. Is that one? Indicated that it's like this. The band is going here. You understand?
That's the flow.
That's the flow. And in this direction, block.
Yeah, I see.
All right. You need to put those diodes exactly like this. And you need to put the electrolytic capacitor. Remember that the capacitor, those capacitors, they have one leg short and other leg longer. The short one is the negative connected into the negative bus bar, and the longer one is that one into the positive. If you put that capacitor wrong, explode. If you put the diode opposite,
It's not gonna.
not rectify. That's okay? And the circuit board burns. I am going to provide you the package, 2 people per table, and you have the board. El negativo. Y aquí del transformador vamos a conectar el hot y el neutro. Y vamos a ver si rectifica. 15.9 voltios DC. Yep. De 120 a 15.9. Congratulations.
Do I have power?
All right, and it's in DC?
Yeah.
Sure.
This is.
Okay.
There you go.
15 volts DC.
Yes. Where's my phone?
1547 DC.
Give me 1 second. I need to take a picture of this.
Yeah, no problem.